Hi, I'm Femi OK. Today on the stream, could blocking out the sun actually help reduce the temperature down here on Earth? Let me show you what I mean. For instance, you could have material pumped into our stratosphere. That material could reflect the sun's rays or solar energy all the way back to the sun, meaning that we down here are kept cooler. That is a very basic, rudimentary understanding of solar geoengineering. There are pros, there are cons, there are knowns and unknowns. There is a debate. Let's take a look.
Should we be pursuing solar geoengineering? The answer is that we just don't know. What we do know is that the impacts of climate change are serious and getting worse, and that we're not doing all we need to do to address the climate crisis. Solar geoengineering might be a useful part of the portfolio of responses, but it also entails a wide range of poorly understood risks. A well-designed research program can help us understand those risks and whether or not solar geoengineering deserves a spot in the portfolio of climate change responses.
Solar geoengineering is a really dangerous idea. It is messing with the global climate system. It is basically just about suppressing some of the symptoms of climate change. It is not doing anything about the root causes, and it comes with tremendous risks for global communities and ecosystems. So instead of betting on high-risk techno fixes, what we really should be doing is get out of fossil fuels. That means coal, oil, and gas, and not expanding any of that infrastructure. And there's really no way we can geoengineer our way out of the climate crisis.
Some of our guests are nodding their heads, some of our guests are shaking their heads. Let the debate begin. Hello, David. Hello, Anjali. Hello, Kelly. Really nice to have you on the stream. David, will you introduce yourself to our international audience?
I'm David Keith. I'm professor at Harvard in public policy and also engineering. I worked on this topic. I worked on climate for about 30 years.
Nice to have you. Hello, Anjali. Tell everybody who you are, what you do.
Hi, everyone, and thank you, Femi, for having me on the show. My name is Anjali Vishwamohanan. I'm an energy policy consultant based in New Delhi, India. I haven't really done research on solar geoengineering. My interest in this space is purely from a person that's interested in climate change and the sort of solutions that we are looking at to deal with climate change.
Great to have you. And Kelly, please introduce yourself to our international audience who are watching right now.
Hi, Femi. It's good to be here. My name is Kelly Wanzer. I'm the executive director of a 3-year-old nonprofit organization called Silver Lining. And our focus in Silver Lining is near-term climate risk. So we drive research. We work with government stakeholders, members of the public, youth organizations to look at expanding our portfolio of options to address climate risk in the next 30 to 40 years, where we may have some gaps that might not be addressed in other ways.
Thank you, Kelly. Thank you, Anjali. Thank you, David. And audience, I know you have thoughts on this. I know you've got opinions, and maybe there are a couple of things that you want to ask our lineup, our guests. Jump into the comment section, and you too can be part of this discussion. The idea, Kelly and David, that solar geoengineering may well be a climate change solution. David, you go first.
So solution is a loaded word, and that picks up exactly on the critique you heard, which is the idea that it's the sole solution. Nobody in this debate who's remotely sensible thinks it's a solution. Just put that off your shirt. Right. What it may be is a way to substantially reduce risks over the next generation in ways that we cannot achieve by emissions cuts alone. So it may be that the combination of emissions cuts and solar geoengineering could be significantly safer, particularly for the world's most vulnerable, than would be emissions cuts alone. But no single thing is a solution. Even emissions cuts alone are not a solution because we clearly need adaptation. A complicated problem like climate change has many different things we need, one of which may be this technology.
Kelly, one of the things that we found as we were putting this show together, the stream show together, was trying to find out all of the different ways that maybe you could reflect off the sun's radiation, the energy, so you could cool our climate, if that was possible. I'm looking here on my laptop at marine cloud brightening, science, feasibility, and a plan for research. Can you tell us what marine cloud brightening is?
Certainly, and I appreciate your characterization. We don't tend to refer to these techniques as blocking the sun, but rather increasing the reflection of sunlight. So a relatively modest amount of increase in the reflection of sunlight off clouds or particles in the atmosphere can produce quite a large effect in terms of heat energy moving out of the Earth system. And in marine cloud brightening, the idea is based in the image that you showed on observations from things that already happen in the system today, where particles from emissions and natural sources mix with clouds in ways that make them slightly brighter. So in the image here, the streaks that you see in the clouds, those bright streaks, are actually created by the emission from ships. And globally, today, scientists believe that the totality of the particles in emissions, not the particles that produce greenhouse gas effects, but the sort of dirtier kind of pollution particles, one of the side effects is that they mix with clouds in this way. And globally, are thought to be creating something of a cooling effect that we don't understand very well. The idea behind marine cloud brightening is to use a cleaner, more benign material like sea salt particles from ocean spray and seawater to brighten clouds over the ocean that are particularly susceptible to the effect. And it's thought, although there's a very high degree of
I'm going to be honest,
around,
you've lost me a little bit, right? You've lost me a little bit. I'm lost a little bit. So help me get back on track. What are you... This is me. You can hear me thinking now, live on TV. Right. All right. So if you were explaining what then goes up into the stratosphere to help cool us, theoretically, what's going up there?
In marine cloud brightening, the material is going into the lower atmosphere. So it's coming up from the surface.
Right.
And in marine cloud brightening, the proposal is it's a salt spray that's generated from seawater.
Okay.
It's sprayed over the ocean into low-lying clouds. And so it brightens patches of these clouds in a way that reflects large amounts of sunlight back to space.
Okay.
In a way that could produce a global cooling effect.
Thank you for speaking slowly. That's
Does
just
that
for
help?
me. Yeah, the audience were like way ahead of me. I'm just like, what did Kelly just say? Anjali, so this is fascinating. There's so much research and science going on here. Why would you be concerned?
Right. So I think the first thing to realize is that, we're on this path where we're hurtling towards a climate emergency, and climate scientists and policymakers have made us all aware of that fact. But the point is that there are two camps of thought on whether we need to pursue solar geoengineering research. One camp says that, we don't know enough about solar geoengineering, and it could potentially be an option that we pursue in case of a climate emergency. And so we need to know more about it, so we need more research. The other camp, which also consists of a different set of scientists, it consists of environmental policy experts and also other governments, such as the United Kingdom, that has put out statements saying that from the research that is available and the research that we've conducted, we feel that we know enough already to make the statement that we don't need more solar geoengineering research because it is likely to cause more detriment than benefit to certain sections of the population or regions. So the question really on solar geoengineering research is that there needs to be a point in this research where we stop and ask ourselves, when do we know enough to make this call on whether we need to progress with research? The point is that solar geoengineering cannot be an indefinite quest to make it a workable solution despite all the risks.
There you go.
I don't think it is.
Yeah.
I think here's what I think we know with real confidence. There's an enormous amount of research now over a decade and a half that suggests that the biggest drivers of global climate risk are peak temperatures. And they're especially drivers for the world's poorest. They kill people, they make people less economically productive, and they make it harder to learn, literally. The one thing we know from every single model, no exceptions, about solar geoengineering is it would reduce peak temperatures and do it in a way that's pretty uniform. It's not like there's some group of scientists with a model that shows that doesn't happen. All models show that would happen. So that's the potential. The only serious paper that looked at the effect of this technology on, say, global inequality showed that it would dramatically reduce global income inequality and would likely reduce global deaths from heat waves. Now, to be clear, there's a big set of risks, and the same community that's researching this has, in a way that I think is wonderful, been often the very first to raise those risks from the beginning. But quantitative answers matter. And despite the kind of stuff you heard in the lead-in, say from the lady from Heinrich Boll, there is not evidence that the risks are really big compared to the benefits. In fact, we now have many scientific papers from researchers around the world on many of the key risks. You shouldn't trust any one scientist. You should trust a group of people that surrounds the world. And to the extent that we know that, each of the risks that we've looked at, the air pollution risks from doing this, the ozone risks, et cetera, they're real. And the community's been one of the first to talk about this risk, but they look relatively small compared to the benefits. And to me, that is the reason to take it seriously. And I think we have to be very careful about people who are pretty rich, who live far from the equator, kind of dismissing this when they're not the ones who are going to suffer the most.
Femi, can I come in here just to respond to David?
Go ahead.
So I think, one of the points that David made is that, that these models suggest that solar geoengineering could be beneficial for certain sections. It could be beneficial for the vulnerable population in the future if we were to implement it. But I think it's important to highlight here that basically the research that's being done into solar geoengineering is being done through simulations in climate models, which helps us understand the impact of solar geoengineering on the Earth system. So scientists that work on these models have recently also produced a paper that lists the various uncertainties in these models, and they've specifically highlighted that it creates challenges in determining the impacts of geoengineering on local or regional climate conditions. So, there are, even with the research that's happening right now, it's not taking into account a lot of regional factors. So, they're not really dependable.
They're not perfectly dependable. Absolutely true. It's the same science, exactly the same models, just a sec, as we use for understanding the impacts of CO2. So just when we add CO2 to the atmosphere, we change the climate, we also can't predict exactly what will happen locally. We can't do it for either. It's the same underlying science. You can't dismiss the science that suggests solar geoengineering might be useful and accept the science that suggests climate is a big risk.
Kelly, can I open this conversation up a little bit more, because we have people online who also have some questions and some thoughts. So I'm just going to go to Solient, who is on Twitter. She says, I'd be interested to know who decides if we go ahead with solar geoengineering or not. The entire world is invested. What if there's a 20% chance of causing damage? Who gets to vote, OK, let's take that chance? Kelly.
So thank you for that question. So that's a terrific question. We believe that this field is a field where scientific assessment is really important. Open science that allows stakeholders from around the world to look at the information is really important. And that government engagement is key. So in Silver Lining, we work with the U.S. science agencies and the U.S. government to help develop a scientific assessment path. And we're hopeful that we can work in the UN arena as well to develop a scientific assessment path that helps stakeholders and government representatives make these decisions in an open and constructive way. The scientific information is critical to that. And I think we disagree with David on the level of certainty that we have around both the efficacy and risks. But that process of driving information so that we can all look at it together is critical.
I'm just looking on YouTube, and Liz Rainey is watching on YouTube. Liz, thank you for being part of the show today. If we do solar geoengineering, how do we force companies to change their harmful practice? My concern is people will keep doing the same harmful things over and over again. David, you touched on this. You didn't say it is a climate change solution, but it can help.
Companies will keep doing the wrong things unless governments force them to stop. So we won't get climate action unless we have government action to regulate the use of the atmosphere as a waste dump for our carbon. That's what climate activists, including me, have fought our entire careers for. No question. It won't just happen automatically. We need people marching in the streets. We need government action. That's what's going to change it. And nothing about solar geoengineering really changes that much one way or the other. Solar geoengineering will provide an excuse, a false excuse, that may be used by some people to try and avoid emissions cuts, but it's wrong. Nothing we know about solar geoengineering changes the fact that we have to cut emissions eventually to net zero in order to have a stable climate.
I'm looking at this image here on my laptop. David, will you talk us through it so that everybody can understand what is going on here and what we're looking at? Because we're still in that phase right now where we're looking at theory, but also trying to do some practical research as well. This is part of the practical research, David.
Yeah, this is an example of a research project called the Stratospheric Controlled Perturbation Experiment, run by my colleague Frank Koich, where the objective is to understand with a stratospheric balloon experiment how some aerosols in the stratosphere, aerosols are just really fine particles that are small enough they don't fall very fast, how they interact with each other, how much they stick together, and how particularly that interaction happens in a plume. And if one was ever going to do this actually for real from aircraft, with much, much larger quantities of material, you would need to understand the details of that interaction. So it's important to say this isn't a test of whether or not solar geoengineering works or not. It's a incremental step to understand a little bit better some of the underlying science.
I want to bring in a voice that's important because I think there's a lot of people not quite understanding what is going on here, but there's still the research that is happening, and then worried about the downside, the negative impact, that what might happen if we change how warm or how cool the Earth is. Have a listen, have a look.
Solar engineering as a technology that is now being touted as one of the solutions for the climate crisis can have many unintended consequences. First of all, it can alter the regional climate, thereby affecting not only the country that is using it or deploying it, but also the countries in the neighborhood. Secondly, it has political connotations because it may divide the world into haves and have-nots, that is, countries that have access to this technology and the ones that do not have access to it, especially the developing world. Thirdly, it may have security implications as well because this technology can be used for dual purposes, thereby creating some sort of insecurity in many regions.
There's a whole list of concerns there coming from the public. Is there, and I'm just wondering, Anjali, you start, Kelly, you pick up. Is there a problem with the public being on board with the science? Is the science is ahead of the public here, Anjali?
So I think there is definitely a level of suspicion and fear in the minds of the public because one is that we all acknowledge that there are a lot of uncertainties and risks associated with solar geoengineering. And the fact that, people and communities or representatives of these communities that are most vulnerable and are vulnerable to the impacts of climate change, they're not really at this decision-making table on where research is going to progress. So, not being able to voice your opinion or not being able to understand what is happening in terms of research creates a further sense of fear and uncertainty.
Kelly, how problematic is that?
Well, we think it's a really important problem to address, but it does take sophisticated resources to study these questions. And I think there's a misperception that the research is moving quickly. The total level of research in this area around the world is tiny. There are a handful of researchers and just single-digit $1 million per year all over the world studying this. And so we think it's actually quite important that we invest resources where they are in the climate models, in the observations, in the tiny experiments that will help us understand these things, and drive to make that information available and make that participation available to people around the world. So, for example, we're working with Amazon Web Services to put global climate models on the cloud that could look at these questions in a way that would allow researchers in the global south and other parts of the world to study them for themselves. So we think the problem is not advancing the science, but the problem is creating the resources and access so that everyone can share in it and then have a voice around the table as to what we're going to do. We have a very serious safety situation. The current best projections have over 1 billion people on the planet displaced. And so we think this is a way of exploring options to see if we can do better than that.
I agree with everything Kelly just said, and I think I want to add one more point, which is it's easy to, on any topic like this, cherry pick people who have opinions in different directions. To the extent that we know anything, and we don't know very much, about what regular people actually think, there's good evidence from 2 papers that people in more climate vulnerable countries are more supportive of research on this. So that's true both among climate negotiators, depending on where they came from, and it's true in Asian countries if you compare rich and poor. Poor countries are more supportive. And in general, it appears actually maybe a little contrary to your implication, Femi, that it may actually be that regular people are more supportive of this than experts. I don't think we know that definitely, but to the extent that we have empirical evidence from surveys, that's the way it appears.
Sure. And it's really difficult, as Kelly was saying, that it's not like this is a big, huge area of research. It was very niche, and it's becoming less niche because our climate is actually warming up. So people are now thinking, what else can we do here? I'm going to show 2 headlines. David, I apologize now because these headlines they're going to be quite painful for you to look at. Controversial test flight aimed at cooling the planet cancelled. Sweden cancelled Bill Gates' controversial climate geoengineering project. This is a project that you're involved in. Bill Gates has put some investment into it. What happened, David? Why was it cancelled?
So I'm sorry, but if you say, I got to interrupt right there. Bill Gates did not invest. That's just plain false. Bill Gates was invest means a financial investment. Bill Gates was one of a whole range, including also the Hewitt Foundation.
David, I did say he was one of the investors. So,
yeah, but it's not, okay.
Yeah. But
investment
what happened,
is typically when somebody has a financial return, which is different from philanthropy, and he had no control or insight into this. I think it's kind of important, actually, when people are saying things that are false. Sorry to get my back up, but I think truth matters.
Absolutely. Well, please continue. The project that was going to happen in June has been cancelled. It was going to be in Swedish Lapland. What happened, and how can you make that connection between what we've been talking about and the cancellation of that practical research project?
So we were only planning to fly there because there's a limited number of places around the world that do high-altitude stratospheric ballooning, and the Swedish Space Corporation turns out to be a wonderful partner for doing ballooning. So we thought that we might fly with them for that reason. And the Sami Council, indigenous organization, and some environmental groups produced a were very negative, argued that it shouldn't happen. And to be clear, they actually concede that it has no risk, but that the risk is the idea, which I think is a consistent view. And they argued that it shouldn't happen. The Swedish government took that seriously and basically told SSC that they shouldn't fly us. That's what happened.
Thank you for sharing that with us. That must be quite disappointing for you and the rest of your team at this point. But I want to bring in another point. This one comes from Catriona McKinnon, who's thinking about, OK, if we get a little bit further along with the science, then what do we need to be thinking about? Here she is.
We need to start a public conversation about solar radiation management soon. And that conversation needs to be focused on the deep and difficult ethical questions that this new technology raises for us collectively. And in particular, we need to start talking soon about how to govern research into this new technology in order to mitigate the risk of the technology running ahead of governance.
Anjali, I'm just wondering, are we there yet? I know everyone's got thoughts. David, you go first.
We should have been talking seriously about governance 30 years ago.
Yeah.
I mean, when I first became involved in this, I and many other people have argued the biggest problem is governance. And we need to begin, governance discussions are hard. We need to begin the conversations early in order to have any chance of making reasonable decisions when the real decisions come up.
Yeah.
The decisions, to be clear, they shouldn't be made by scientists. They need to be made in some organized way that is as legitimate and democratic as possible. But that can't all happen in a second.
Yeah. Angie, I'm just about to wrap up. Final thoughts. Go ahead.
Right. So I think it's important for people to know that research on solar geoengineering currently is being dominated by a group of privileged institutions that is based in the global north. So the only constructive way forward on this is to establish an international governance mechanism that is sort of developed through international participation.
Okay. Thanks, Anjali.
I would also...
We're just right at the end of the show. You brought up a point that needed a new show to talk about that point. But thank you, Anjali, for ending on why the debate will continue. Anjali, Kelly, David on YouTube, thanks for your comments. Really appreciate you. I'll see you next time. Take care, everybody.